So I'm going to talk today about object-oriented programming, and first I want to introduce some different paradigms in programming in general, and when the programming was created in the way we can use it now with the assembly language. It was the program was one huge list of instructions that were performing from the beginning to the end with different jumps, maybe cycles and other stuff. I'm not sure. I think that in Fortran programming language that was introduced somewhere in 1957, and which was presented at the high level than the assembly language. This concept of all the instructions performed in the sequence or written in the sequence, this concept was presented as well. And then, or maybe Fortran was the first language with structured paradigm. Anyway, at some point, the programmers or the creators of the programming languages, they discovered that some parts of the program were used several times, and no, not some parts, but in the program there were parts of the code that had the same functionality, and these parts of the code happened over and over again, because at different points the programmers wanted some particular functionality. So the creators of the programming languages found the new paradigm, which is a structured programming, and the code was put into separate blocks of code, and these separate blocks were named functions, and each function had its own name. So the programmer could call one particular function from different places in the program code, and the programmer didn't need to duplicate this code again and again. He wrote the code once, coded a function with some particular name, and then just called this named function as many times as he wanted. And this approach had its own benefits, like there was no code duplication. This functionality was written once inside the function, and then the programmer just put calls to this function into its own program. So instead of writing, let's say, function call, writing 12 identical codes throughout the program, the programmer just wrote 12 strings or single line instructions that code this particular function. So it was the saving of the space for the program, and the program became more error, or maybe less error prone. Yes, less error prone, because when you write your code just once somewhere in the program, you can edit it and add some additional functionality to it. But when you write the same code throughout your program 12 times, it's easy to you to make mistakes somewhere in these 12 identical pieces of code when you start to edit, to change these parts of code. Let's say you need to add some new variable to your function, and you need to make these changes in 12 parts of your program. It's more likely for you to make the mistakes somewhere in these parts, or maybe to forget to change one of these 12 parts of code. But when you change only one piece of code which has some particular place and which is a named function, it's more likely for you to make these changes right, and then the other person, the reviewer, can check your changes in this one place, and to guarantee that the function works quite well. And yeah, this is the structured paradigm in programming, and it was implemented in C language, and C language was the basic language for writing Unix operating system, so it's quite possible to get all the functionality that you want from this structured programming. Yeah, but then the paradigm of objects appeared, and the new paradigm, object-oriented programming, was created, and the C++ language is one of the examples where the language was based on the C language with its structured paradigm, but then the objects were added and a new language was created, C++, and plus means the improvement in this particular language over its predecessor, which was C language. Another example of improving C language with the OOP paradigm is Objective-C language, which took the similar approach to C++, and Objective-C based on C language plus some additional objects, and this allowed Objective-C to be considered as object-oriented programming language, but Objective-C and C++ were not compatible. So object is some logical idea that looks at the surrounding world and uses the real objects from this world inside the programs. Like you can program the car object, the color, the animal, and all of these are the examples in many textbooks for understanding object-oriented paradigm after you came from structured programming. And object can have data and methods. For the car object, the data will be maybe the number of wheels, or the type of the car, or I should I say vehicle, and then for the vehicle we can define some, what did I say? Well, maybe I said methods, but I wanted to say properties or attributes. So for the vehicle, the properties can be like the number of the doors in the vehicle, the number of the wheels, maybe the weight of the vehicle, the color, the type, like allowing get passengers or not, and the methods for this vehicle could be like start the vehicle, stop the vehicle, add petrol to it, and different other stuff. And these properties and methods are kind of natural attributes and activities of such objects in the real life. And objects are the like living instances of classes. The class is the way for you to describe the object. It's like a blueprint with which you define what your objects will be like. But each object is an individual entity, instance that was created from this blueprint. Like the house is an actual instance that was created from the architectural blueprint, or some clothes, the suit is an actual instance that was created from the blueprint drawn by the designer on the paper. Classes and objects, yeah, and each object is characterized by these individual properties that are initialized during the creation of this object. For example, for the class vehicle, you know that the vehicle will have some model, model number of doors, number of wheels, the color and other stuff. But when you create the actual instance, you give this instance some of the properties, and there is no possibility. These properties are defined like what? These properties are defined for this vehicle. Let's say the car with the model Volvo with 4 doors, 4 wheels, and let's say the silver color. Or another vehicle, maybe, I don't know, Hyundai motorcycle with 2 vehicles, no doors, let's say red and black color. So yeah, that's it for relationship between the instance, the object, and the class, which is the blueprint for this object. Object-oriented programming focused on creating these classes and objects as the main citizens of the program. Yeah, and you need to think in the way of these objects, and these objects can interact with each other and with the user. Yeah, in this structured programming, you think in terms of maybe algorithms, the way the program performs is performed from the first line to the end. Yeah, like creating array, then calling some functions that perform the operations on this array, and then printing out the numbers inside the array. But for object-oriented programming, you think about some entity, and then you add some properties to this entity and some methods to this entity, and the interaction of this entity with other entities. And there is a catch that most of the people, when they try to switch from the structured programming to the object-oriented programming, they just create some huge class and put all the variable from the program as the methods, as the properties of this class, and all the functions from the program as the methods of this class. And basically they just named the previous structured program as the class, and it didn't make the programming style object-oriented, because the way you look at the entities which are the most important in your program, this way defines what style you use. And for some short scripts that you need to, let's say, process some text files, get some information, and print some other information, you don't need to create all these objects. You will be just fine with the structured programming. But in some huge programs, object-oriented programming will help you to keep your code more concise, more effective, because well, it all depends on the purpose that your program plays. Well, anyway, so these objects from OOP can have these methods, these properties and methods that can operate on these properties. Like the most common methods are setters and getters, which are used to initialize and get the values of the properties of each object, so that the property could not cannot be changed, like, I don't know, couldn't be changed in the straight way. Yeah, and these setters and getters will help to secure your program, your objects, from these random changes by the other objects or even other programs. I don't know. This is the area which lies behind the basic knowledge of this OOP paradigm, but more in the experience of programming this stuff, and to name something of this security type in object-oriented, I needed to see some real example and then to describe it. I can't really find something from my head. Anyway, there are three main parts, or maybe ideas, in the object-oriented programming, and they are inheritance, encapsulation, and polymorphism. And encapsulation is the first part of OOP, and it's about getting all the methods and all the properties which represent some logical entity in the real world together within the object. It's like what I just described about creating the object itself, but this idea has its own name, encapsulation. And another benefit of this encapsulation, that you can provide some security for the data by making this data private and allowing any changes to this data through the methods. And in these methods you can implement different checks for the parameters that you put, with which you call your methods, and if these parameters are invalid, then they have no effect on your properties. This way you protect your properties from invalid data or from some other unauthorized accesses, for example. So encapsulation is quite intuitive part of the OOP, and the next method is inheritance, and it's quite intuitive too, because let's say we create shape class, and this shape class has some attributes, like some, or maybe let's say now we have several classes or objects like circle, triangle, rectangle, maybe oval, and all of them are shapes, and all of them have some common characteristics like area, the perimeter, that's enough, I think, and we can extract some common characteristics and put them in the class in the class which is more common than all these shapes, and we call this class shape. So this shape class will have two basic properties like area and the perimeter, and maybe some basic methods like get the perimeter, get the area, maybe fill or set the color for the shape. But because this type is quite common, we can't say what shape can be created from this from this class. It's more like abstract class that has some common characteristics, and then we define we create subclasses, we inherit something from this common class, superclass, and create subclasses like circle, triangle, and rectangle. And by using this attribute, this magic of inheritance, which is implemented as the part of OOP, the subclasses get all the basic characteristics from the shape class, area, perimeter, and methods like get area, get perimeter. But then we add some specific characteristics that distinguish the circle, for example, from different shapes. Like for the circle we can add radius, or some point, basic point of the circle on the canvas, like the center of the circle. For the triangle we can add the lengths of the sides and the angles between those sides. For the rectangle, we can add the length of one side, and we can take as this basic point of the canvas the coordinates of one of the corners of this rectangle, yeah, and all of these characteristics will be unique for each of these objects, and we add them into the subclasses. But the basic characteristics like area and the perimeter are common for these shapes, and these characteristics, these properties, are inherited from the superclass. And for the methods, all the methods like get area and get perimeter are inherited as well, but in the subclasses, these methods are overridden because to calculate the area or the perimeter of the circle and of the rectangle, you need to use different mathematical equations, and you use the right equation for each of the shape. But also you can add some additional methods which are unique for the subclass and which are not in the superclass. For the rectangle, we can rectangle. Yeah, when I said rectangle, I always thought about the square. Yeah, the square. So let's consider with the square. So for the square, we can add the method set aside, and for the circle, we can add a method set radius. Yeah, and these methods are unique for these particular subclasses, and they are not in the superclass. So this hierarchy part of the object-oriented programming helps to keep these relationships between the common classes and more specific classes, and again have the helps to have all the methods that are unique for one type of hierarchy in more common superclasses, and more specific methods put in the subclasses. And this is the second part of OOP programming. First one was the encapsulation, the part, or maybe I can find the word, maybe in the end of this video I will find the necessary word. The second principle in object-oriented programming is the inheritance, and the third principle is the polymorphism. And this is a very powerful thing, but it is quite difficult to understand, because most of the time it's possible to live without it. Yeah, and one of the examples of this polymorphism is what? When you have a function that takes some shape like circle, and then you need to print then you need to print the area of this circle, and then you have an array of different shapes. So to print the area, the parameter and perimeter and other characteristics of each shape in this array, and array can have circles and rectangles, squares, ovals, and other different types of shapes, not only these three that I described earlier. So when you want to print all the characteristics, lots of characteristics for each shape, you need to have, without polymorphism, you need to have a lot of functions that can work on with each type of the shape, like for the circle, for the square, for the triangle. But when you have this polymorphism principle, you write this cycle, the function that goes through the whole array. And of course, first of all, you can set the array of the type shape. And because this shape type is the superclass for all other shapes, you can put into this array circles, what else? Squares, rectangles, and it will compile correctly, because without this polymorphism, you have to have different arrays for each type of the shape, like the array only for circles and array only for triangles. And then you put this array of shape type into this function or array that gets the variable of shape type, and then calls on this shape type, abstract shape type, the methods that are common, that this shape type has, and these methods are common for all the subclasses by the definition of subclasses and the superclass. So in this abstract function, you take this shape method, shape class, and calls on it. You take and call on it the methods that are available in the shape superclass. And then when the actual execution of the programming will be performed in the runtime phase, not the compile phase, but in the runtime phase, then each object from the array will be put in the place of this abstract shape superclass, and for each object like circle or triangle, the specific method will be called. So shape dot get area, and will change in the runtime like circle dot get area, and shape dot get perimeter will be performed in runtime, like circle dot get perimeter, and this will work for each object, for each superclass in the array. So this is the third principle in OOP, and they are encapsulation, inheritance, and polymorphism. Yeah. And to conclude this video, I will say about one more paradigm of programming, which is functional programming. And this functional programming is in another way to create programs, but it's not so natural as the object-oriented programming, and it's not so simple as structured programming, because, well, in structured programming you can write all your code from the beginning to the end, the next instruction, the next step in the operation that you want to take, and code it as the next instruction. Sometimes you can call functions when you have some code that you need to use several times, but you can easily put all the functions within this huge piece of code, and your program just perform this code from the beginning, from the first line to the end line. But the functional programming tells that you can't create any sequences of instructions like with the structured programming, and you can only call functions from the functions. So they have some way to put inside the main function. They have some way to put several functions in this sequence inside the main function, and it looks like this structured way of programming, but it's just some syntaxis sugar, because in fact all these functions somehow all these functions use the output from the previous functions and put their output to the and give their output to the preceding functions, to the functions that follow. Yeah, but the main idea is that you can't perform two instructions in a row. You just need to call the function that will call the function, and so on. And it's very unnatural way of programming, because it's not like we think in this sequence of operations from one to another. It's not like we think in the objects that exist in the real world, but it's the pure mathematical way of thinking when you operate only with functions. And this type of programming found its implementation in Haskell programming language, but it's more, this language is more academic, is used for academic purposes, because most of the function of the programming languages with the function paradigm, they use the combination, the mix of the function programming and object-oriented programming. Yeah. So I think now I made more than 40 minutes of the recording, and for now, for today, I'm going to stop with the today's video.